Okay, so this problem is dependent on the previous problem. So the previous problem was basically based on projectile motion, in which uh, from the surface, let's say this is the surface, particle is projected at an angle alpha. Okay, and follows this parabolic kind of a trajectory, right? And lands on the surface here. So let's say starts at some point A and ends at some point B. Now what they're saying is draw the approximate time dependence of the moduli of normal Wn and tangent W tau acceleration vectors, as well as of the projection of the total acceleration vector Wv on the velocity vector direction. Okay, so let's first understand what is meant by this normal and tangent acceleration vectors. So at any point, okay, at any given time t, at any point in the trajectory of the particle at some time t, the velocity will be making some angle, say theta, right? This theta is of course between 0 and alpha, okay, inclusive of course. So it will be 0 at the peak and alpha at the starting and the end. I mean, of course, when it is over here, it will be mine. So yeah, so after the peak, basically this angle is negative. So actually, I was wrong. It should be varying from minus alpha. Sorry, varying from minus alpha to alpha, both inclusive, right? So let's say at some time t, it is making an angle of theta, the horizontal. So what do they mean by this tangential? So first of all, let's see normal. What is normal acceleration? So see, the main acceleration is only due to acceleration due to gravity. There is no other acceleration source. So there is no other source of acceleration. There is only acceleration due to gravity. So if we just, I'm just drawing this part here. I mean at this t, velocity is making an angle theta. So some v, okay. The acceleration is downwards g, right? Now the thing is, in the normal acceleration, so first of all they're asking just the moduli, okay? Moduli means just the magnitude, I mean just the positive magnitude basically. So it will have obviously the normal component normal to the velocity is the normal acceleration, and component parallel to the velocity is the tangential acceleration. So normal to the velocity, okay, sorry, component normal to the velocity is, so if this angle is theta, this angle will also be theta, because this angle in between, this will be 90 minus theta and this will be theta, right? So basically that this is a 90 degree, right? So this is 90 minus theta, and since again this and this also form a right angle, this will be theta, right? So this over here normal component will be g cos theta, okay. And see, since theta varies from minus alpha to alpha, right, and cosine of obviously positive angles is positive, and cosine of negative angle This is all between, of course, this is the value of alpha is between 0 and 90 degrees. So basically this is between minus 90 degrees and plus 90 degrees. So cos of that angle is always positive, right? So yeah, okay. And if we, this is directly the modulus, because it's positive, always positive, of the, this is the normal component. What about the tangential? Achha, so what is the notation? Wn. This is your Wn. What about the tangential component? Only the magnitude we want right now, okay? So in this case it is g, okay, it is g sine theta, right? But yeah, sine theta for negative angles it is negative, so I would put a mod, g of mod of sine theta, okay? Okay, that is your magnitude of tangential component, modulus of the tangential component. Okay, so now we need to make an approximate, like time dependence sort of a graph. Okay, so the critical points would be t equal to, let's say the whole time taken is tau. Okay, so the critical times would be t equal to 0, t equal to tau by 2, where it is at the maximum height of ascent, and here t equal to tau. So these are 3 points of like interest, right? These 3 points will sort of make the main points of the graph, and then we'll see how the slopes vary with time also. All right, so now see, basically we need to see how this theta varies with time, how cos theta and sin theta vary with time. If we can just plot that, then we are done, because it's just a constant g multiplied by that. That's it, right? Okay. Okay, before that, let's see, let's make a table of only at the, like at t equal to 0, t equal to, sorry, so this is the, obviously the moduli wn w tau, okay? W tau right, and the critical points. Okay, so there are 3 critical points: t equal to 0, t equal to tau by 2, t equal to tau. Okay, now at t equal to 0, yeah, theta is equal to alpha. At t equal to tau by 2, theta equal to 0, and t equal to tau, theta equal to minus alpha, right? Okay, so at t equal to 0, t equal to 0, it is so see, one thing which is to be noted, I'll obviously write the values, but yeah, so like the graph would be symmetrical about t equal to tau by 2. So now why is that? That is because if we consider times which are equidistant from t equal to tau by 2, right? Okay, so for those cases your angles would be theta and minus theta. Okay, let's say some 2 time instants which are equidistant from this tau by 2, we take the angles, it will be theta and minus theta, right? Now if we consider the accelerations, g cos theta and g cos minus theta will give you the same value, Similarly, g mod sin theta and g mod sin minus theta will give you the same value. So it will be symmetrical about t equal to tau by 2. So symmetrical about t equal to tau by 2. This is an important property, right? Okay, let's find out the critical value. So at t equal to tau by 2, sorry, at t equal to 0, theta equal to alpha, so Wn is g cos alpha, w tau is g sin alpha. Same goes with theta at t equal to tau. Same, as I told, it is symmetric about t equal to tau by 2. What about t equal to tau by 2 at theta equal to 0? When theta is 0, g cos theta, so cos theta, wait a second, cos theta becomes 1, so this becomes g, sin theta becomes 0, so this becomes 0. Fine. Okay. Now, so see, basically we need to just form the graph from 0 to tau by 2, and then from tau by 2 to tau it will be a reflection about the t equal to tau by 2 axis, or sorry, t equal to tau by 2 line. That's it. Okay. So, and also another benefit is that from t equal to 0 to t equal to tau by 2, the theta values are positive. So that just helps. Theta values are between 0 and 90 degrees. That helps. Okay. So like the sine alpha, yeah, I should mention this mod sine alpha. Here will be g mod sine alpha, but since alpha, I mean, yeah, of course alpha is positive. Sorry. So this is also g sine alpha, this is also g sine alpha. But yeah, I'm just saying from t equal to 0 to t equal to t tau by 2, mod sine theta is equal to sine theta. Yeah. So yeah, because these angles are between 0 and pi by 2. Just wanted to mention this. Fine. Now let's cut to the chase. So now I know the critical values. I need to find out what would be the slopes at those points, right? See, because it will be a roughly continuous graph, that much is for sure. So let's see. And so basically we need to find out the dependence of cos theta and sin theta with respect to time, right? So if we consider again, like, so horizontal velocity would remain constant. So let's say your initial velocity is velocity magnitude is v naught, then v naught cos alpha equal to, let's say time t it is v cos theta. This is one equation. Another equation would be, like, in the y direction, v equal to u plus at, right? So vy will be v sine theta is equal to u, which is v naught sine alpha plus at. It will be minus gt because gravity is in the negative direction, negative y direction, so minus gt. Fine. Now if we can yeah, so we can do one thing. We can basically try to eliminate v because we need theta in terms of t. So from the first equation we have v equal to v naught cos alpha by cos theta. Okay, now this we substitute in the second equation. This becomes v naught cos alpha cos theta times sin theta equal to v naught sin alpha minus gt. Okay, now so basically what we are getting is let's say we divide both sides by v naught cos alpha. Okay, so we are getting a tan theta equal to tan alpha minus gt, okay, gt by v naught cos alpha. Right? This is what we are getting. Now if we consider capital A as say tan alpha. Okay, let's say capital A is tan alpha and capital B is g by v naught cos alpha. It just to make our simplification easier, we can substitute these terms also back later if required. This becomes a minus bt, and of course a greater than 0, and of course yeah, b is also greater than 0, right? Okay, and a and b are obviously constants, right? Now what we can do here is so there are two ways we can handle this. Okay, let's handle it in this way, that let's say we first want to see what is d cos theta by dt, right? Let's say, so what is d cos theta by dt? It is nothing but minus sin theta d theta by dt, right? Yeah. Now let's use this. Let's differentiate both terms with respect to t, right? Tan theta becomes secant square theta d theta by dt, right, equal to, and if we differentiate with respect to differentiating with respect to t, this becomes minus b. Acha, one more thing, we need both d sin theta by dt, because see, we need to see how g cos theta and g sin theta vary. That is why I am just doing d cos theta by dt and d sin theta by dt. This becomes cos theta d theta by dt, right? Just need to see the nature of the slopes, because I am not finding the exact sort of equation, right? Leaving it in terms of theta. Okay, anyways, we'll get to it. So we get this from this. So let's first concentrate on d cos theta by dt. Okay, so this becomes minus sin theta. Okay, sorry, before that, my bad. Before that, d theta by dt is equal to minus b cos square theta. Okay, right. Now we consider d cos theta by dt right? Okay, let's also, yeah, this is nothing but g cos theta is wn. Okay, so basically 1 by g times dwn by dt. Okay, you can write it this way, right? So this is nothing but minus sin theta times d theta by dt, which is minus b cos square theta. Okay, so from here, dwn by dt equal to b sin theta cos square theta. This is dwn by dt. Similarly, d sin theta by dt, right, is equal to 1 by g. This is only for 0 to tau by 2 we're talking about. That is why I'm not taking mod and all. So this is 1 by g times dw tau by dt, right? So okay, and from here, what is d sin theta by dt? Cos theta d theta by dt, which is nothing but cos theta into minus b cos square theta minus b cos cube theta. Okay, so dw tau by dt is equal to minus bg cos cube theta. Okay, fine. Now it's very simple from here. As you can see, with time, yeah, we just need to see the trend, right? That's what we just need to see. So with time, as dwn by dt, and we are only considering, okay, I'll just try to the different color here, for t equal to 0 to t equal to tau by 2. For this period, the slope is greater than or equal to 0, right? Of course, at tau by 2 theta becomes 0, so the slope also becomes 0, right? At t equal to tau by 2, dwn by dt becomes 0, right? And as your theta decreases from t equal to 0 to t equal to tau by 2, what do you think will happen here to the magnitude? So imagine theta is decreasing, right? Theta is dropping. So another way to write sin theta into cos square theta is nothing but, you can write cos square theta as so yeah, you can write cos square theta as 1 minus sin square theta. So this becomes b into sin theta minus sin cube theta. Okay, right. So as theta keeps on decreasing, okay, the sin theta value itself keeps on decreasing, okay, right? And sin cube theta value keeps on decreasing even further, because the cube of a quantity between 0 and 1 is much less than the original, right? So overall, this whole quantity keeps on decreasing. So as theta keeps on decreasing, dwn by dt also keeps on decreasing. That's what you need. This is done. Now over here, what is the situation? Again, for t equal to 0 to t equal to tau by 2, what happens? dw tau by dt, so see over here, it's minus bg cos cube theta, t equal to 0 it is minus bg cos cube alpha, right? And at t equal to tau by 2 theta is 0, so it becomes minus bg, so it is always negative, right? And yeah, at t equal to tau by 2 dwn by dt is equal to what? Minus b, right? And as theta keeps on decreasing, so imagine it this way. Tau. What happens to dw tau by dt? As theta keeps decreasing, right, from it is, yeah, it's going nearer and nearer to 0, cos theta value will keep on increasing, right? It becomes closer and closer to 1 as we approach towards 0. So as theta keeps on decreasing, cos theta value keeps on increasing, but there is a negative sign. So essentially dw tau by dt also keeps on decreasing, right? But we know that dw tau by dt is less than 0, basically, which it means that it keeps getting more and more negative. And of course at t equal to tau by 2, because this cos cube theta, the magnitude, if we just see the positive magnitude, it is at its maximum, so there the magnitude of the slope would be maximum, right? So now let's roughly plot like what is happening. Okay, now we plot. So let's say this is the time axis, right? This is t equal to 0, this is t equal to tau by 2, this is t equal to tau, right? We have the y-axis. Of course we are dealing with right now moduli, so we just need to concentrate on the positive y-axis. Okay. And the maximum acceleration which is possible is of course g, right? Okay. And okay, so now let's see, and we'll first go with wn, right? So what is happening to wn? So if we consider this table, for wn initially it is g cos alpha, then it grows to g, then it comes back to g cos alpha. We'll only plot this plot first till tau by 2, and we'll just reflect it with respect to tau by 2. So wn varies from g cos alpha to g. So g cos alpha, okay. Now you'll observe that there are two key values, g sin alpha and g cos alpha. So it depends whether like the angle is alpha is more than 45 degrees or less than 45 degrees. I don't think yeah, it's not mentioned in the question anywhere, so we'll just assume one of the two, right? Let's just, I guess, assume and check the question once if there is any mention of okay, I guess we'll assume that alpha is small, so g cos alpha is greater, let's say, right? G sin alpha is somewhere here, so we utilize that. Now from 0 to tau by 2, as I already said, the value of wn varies from g cos alpha to g, fine, and we see the differentiation dwn by dt at t equal to tau by 2 it is 0, at t equal to 0 it is some positive value, right? So we can say this is some sort of a maximum at t equal to tau by 2. starts from here, and yeah, as theta keeps on decreasing, dwn by dt also keeps on decreasing, right? So start somewhere here, goes till here, and of course at tau again you have this same value of g cos alpha, right, as I have already sort of mentioned. These are the key points. So it is symmetrical about t equal to t tau by 2. So we'll just, this is sort of a rough plot of, this is for wn, this is wn. Now let's see what is w tau. So w tau at t equal to 0 it is g sin alpha, at t equal to tau by 2 it is 0, right? So this will use this color. So it is over here first, then here, then again it comes here. Okay. Right. Now we just need to see what about the slopes. We will draw till tau by 2 and then we will reflect it. That's one. So till tau by 2 the slope is negative. At t equal to tau by 2 the magnitude of the slope is the highest. Okay. Yeah, the magnitude of the slope is the highest. However, the slope is always negative, and also as theta keeps on decreasing with time, it becomes more and more negative. So initially it starts off with some negative value, the slope, then it becomes increasingly negative till we reach tau. Now as we said, it should be a reflection, so we just draw a reflection. Right. Done. So this is basically, we are done with plotting wn and w tau. Now we need to go to the second part of the question, which is fairly simple once this part is done, which is we need to see what is the projection of the total acceleration vector wv on the velocity vector direction. Okay, this is similar to the tangential acceleration, but instead of the modulus they are asking the projection. So this is quite simple to understand. It should in the velocity vector direction. Okay, so from 0 t equal to 0 to t equal to tau by 2, let's see, right, from t equal to 0, from t equal to 0 from t equal to, sorry, t equal to 0 to t equal to tau by 2. Okay, so for this what is happening is, it is at any time t it is making a positive angle with the horizontal from theta. Okay, so the component of the acceleration, actual acceleration, is g, right, in the direction of the velocity v at some that point t, is in that direction is obviously negative, right, because this angle is obtuse, and cos of an obtuse angle is negative. So t equal to 0 to t equal to tau by 2, it is negative. But if we consider from t equal to tau by 2 to t equal to tau, right, and this is all regarding wv, and the component of the acceleration in the direction of the velocity vector. So t equal to tau by 2 to t equal to tau, the component, it is basically makes a negative angle, right, and g is this way. So this is an acute angle. So so since it is an acute angle, because it's making some negative angle with the horizontal, the component becomes positive. Now note, the magnitude, the modulus, is nothing but the tangential acceleration modulus that we found, because the component is along the direction of the velocity. It's just that over here we are also considering the sign. That's the only difference. So we just need to see, and basically the sign changes at tau by 2. So from t equal to tau by 2 to t equal to tau, it is positive. So it's basically just same as w tau, from t equal to tau by 2 to t equal to tau. So this is w tau comma wv, right? This part at least. And from t equal to 0 to t equal to tau by 2, since it is negative, the sign is changing but the magnitude remains the same. Just a reflection, right? Because see, the thing is, magnitude will remain the same, only the sign will change. It becomes negative, so it will just be a reflection. I'm using the same color, but it will be a reflection, and obviously this value here will be negative g sin alpha, and yeah, this becomes a wv. There you go. This is the rough plot for the normal acceleration, tangential acceleration moduli, as well as the component of the acceleration vector along the velocity vector. So yeah, so one thing to remember here is, of course, like this could also be sort of, you can also arrive at this using intuition, especially if you are appearing for like exams which require less time for the question to be answered, especially in multiple choice questions and all. It helps if you do it by intuition. But yeah, over here I showed you sort of a full proof method where you use critical points. Over here they are t equal to 0, tau by 2 and tau, because anyways we do not need the exact curve. And also a method where we can get like the trend of the slope with respect to time, so that we can, at least the nature of the graph we can plot. So that's that. Thank you.